Hello friends, and welcome to a chat from the engineering desk. What we have here, an Arduino Uno, an analog Hall effect sensor, a 2x16 LCD display, which is I2C. That's connected to A4 and A5, and then the Hall effect sensor is connected to A0, and we have an LED to indicate what's going on. So here we've got a north pole and a south pole. One side takes the voltage low, the other side takes the voltage high. The LED gets brighter. Let's put it in the drilling machine. And there you can see it measuring the speed. Like that. Right. Very good. So we've covered the wiring. Alright. These three components, well, 4 with the LED and a 330 ohm resistor because it's 5 volts. Right, let's have a look at the code because I want to see how it works. Right, off to the bench. Bring the microphone closer. Right, so in the code, sensor pin is a 0. Magnet count is 2. That's our thresholds because we're using voltage detection to detect the magnets coming past. Variable, we got sensor value 0, which is an integer. We've got pulse count, a volatile integer. Boolean, which is magnet detected. We start off with it false. Then we got a timer variable, and then we got a floating variable, which is RPM, which is for the output. Now we initialize I2C, address 27, 16 characters, 2 lines. For debugging, we've got serial comms, so we initialize the serial port at 9600 baud. Initialize the LCD. Turn the backlight on, set the cursor at line 0, position 0, and we write RPM sensor on that position. Then we reset the pulse count, and then we go to the loop where we do an analog read to look at the voltage. We look at the sensor value, and we look at the threshold high, so we return a boolean over here depending on whether the voltage being read in is above or below the threshold, and every time that changes we do a count, and then we change the state of the magnet that was counted. And over here, if it's below the threshold value, then we reset magnet counted. Now once a second we update the value, so the number of pulses that were counted in 1 second becomes RPM is pulse count times 6.0 times magnet count, which is 2. Pulse count is reset to 60 because we did 1 second. Now we reset the timer. To display the RPM on the LCD, we set it to position 0, line 1, so it's a second line. We write RPM, and we then print the RPM and we scale it. So we multiply it by 10.0, so that's a floating point calculation, and then we clear extra digits from the previous write. And then for debugging, we write sensor value, RPM and RPM, so that's that result before we printed it with the 10 times multiplication, like that. And that is the code. Just a little bit of simple code that's using an analog RPM sensor. Right, so I hope you enjoyed this quick little video. Thanks for being here, ladies and gentlemen. Hope you have an awesome day further. Take care, and we'll see you next time for more awesome stuff. Alrighty, cheers.